Welcome to this lesson. I want to tell you that if you have any topic that is giving you a problem, don't hesitate to comment or text. There is my phone number there. Just contact any topic that is giving you a problem. I will assist you to achieve your dream in biology, chemistry, and mathematics especially. So if you have a topic that is very difficult for you, you don't understand, don't hesitate. Usisite. Just comment and I will make it simple than you think. I will make it simple than you think. Don't forget to subscribe, comment and like. Welcome. Let me take you through this revision, chemistry. The diagrams you are seeing here. The diagram below represent three methods of collecting gases in the laboratory. So we have three methods here. Name the methods shown in the diagram. How will you know which method is that? This method, you can see there is water here. Therefore, this method A is called over water method. This method is the delivery tube. This one is called the delivery tube. You should know that. Delivery tube. So when the delivery tube comes and gets into water, is directed towards water. That one is called over water method. Right? B. Look at the delivery tube. When the delivery tube comes and then it bends upwards, that's what you look at. The delivery is bending upwards. That one is called upward delivery, because this delivery tube bends upward. Look at this one. The delivery tube is coming like this, inakuja hivi, halafu inateremka chini. It comes down. So that one is called downward delivery. Downward delivery. So another name for upward delivery. So when the gas is collected by this, the air that was inside here is displaced downwards. So this one is also called downward displacement of air, because when the air is getting into it, the air that was inside there is displaced downwards. It is called downward displacement of air. Downward delivery is also called upward displacement of air. Why? When this air, which is denser than air, gets into the gas jar, the air that was inside there is displaced going up, right? Therefore, that the air is escaping upwards, it is called upward displacement of air. Upward displacement of air. State the reason, with reason, the most suitable method for collecting each of the following gases: oxygen, hydrogen, and carbon dioxide. So these methods, the gas to be collected with any of this method has some properties. So you should know that gases collected by over water method, they are slightly soluble in water. Slightly soluble in water. Gases collected by upward delivery, they are lighter than air, or they are lighter, they are less dense. When it is lighter, they are called less dense than air. Gases collected by downward delivery, they are denser than air. Denser than air. So oxygen is collected by over water. Over water, because it is slightly soluble in water. It is slightly soluble in water because it is collected by over water method because it is slightly soluble in water. Hydrogen is collected by a method B. B is hydrogen, therefore P is because hydrogen is less dense than air. Carbon 4 oxide. The property for carbon 4 oxide which makes it to be collected by downward delivery, so the method here is C, because carbon 4 oxide is denser than air. So the method of collection depends on the density of the gas and whether the gas is soluble or insoluble in water. The chart below, the flow chart below shows the result of two solids. M was subjected to several conditions or reagents. Study and answer the question that follow. So we have solid M undergoing this direction. It is undergoing heating. This direction is reacting with HCl. So this solid, when it is reacting with HCl, it forms carbon 4 oxide, water, and solid B. So when you can see carbon 4 oxide here, then it means this solid must be a carbonate, because a carbonate plus an acid gives you salt, water, and a carbon 4 oxide, and therefore this is a salt, right? And then on heating solid M, it gives you a solid R. The characteristics of solid R, it is yellow when hot or white when cold, and that one is zinc oxide. It is only zinc oxide will behave like this. Zinc oxide is yellow when hot and white when cold. So if this is zinc oxide, then it means this one is zinc carbonate. It means this one is zinc carbonate. So that's how you analyze the equation. So solid M is zinc carbonate. So solution B, this one is zinc carbonate plus hydrochloric acid. It will give us zinc chloride, water, and carbon 4 oxide. Therefore solution B is zinc chloride. Gas Q, when a carbonate is heated, it gives what? Carbon 4 and zinc the oxide. Therefore this one is carbon 4 oxide. Solid R is zinc oxide. Write the equation for the reaction in step 1 heating. So zinc carbonate, a solid, when you heat, it gives you zinc oxide plus carbon 4. This is a gas and this is a solid. Step 2, it is the reaction with the acid. Therefore zinc carbonate, a solid, plus HCl, it will give you zinc chloride, solution B, plus CO2 plus water. This is a liquid, this is a gas, and this one is aqueous. Because chloride here there are 2, you write 2 here to balance the equation. And that is the equation. Dilute sulfuric acid was added to a compound Q of sodium. The solid reacted with the acid to form a colorless solution K and a colorless gas J, which formed a white precipitate when bubbled through lime water, calcium hydroxide. So whenever you hear a colorless gas which forms a white precipitate with calcium hydroxide, which is lime water, that gas is always carbon what? carbon dioxide, because the test for carbon dioxide is that we bubble carbon dioxide through lime water and a white precipitate is formed. So name the compound. Compound Q are the only solid or compound that react with sulfuric acid to form carbon dioxide, plus then that one must be a carbonate. If it is not a carbonate, it is an hydrogen carbonate. Therefore, compound Q is likely to be sodium carbonate or sodium hydrogen carbonate, because these are the only two compounds which will react with the sulfuric acid to form carbon dioxide, water, and the salt. Solution K is the salt in which water will have there. So solution K is going to be sodium sulfate. The colorless gas J is carbon 4 oxide. Carbon 4 oxide. The next question will be to write an equation between Q and dilute sulfuric acid. We have said Q is sodium carbonate. So sodium carbonate is Na2CO3, a solid, plus sulfuric acid aqueous will give you sodium sulfate plus what carbon 4 and then plus water. Aqueous. We need to balance anywhere? No, everything is balanced, and that is the equation. Explain why cars in Mombasa rust faster than cars in Kisumu. Remember, there are two. We know the conditions necessary for rusting is oxygen and water or moisture. These are the two conditions which makes a substance to rust. But why is it that cars in Mombasa rust faster than cars in Kisumu? We have two factors that accelerate, that speeds up the rate of rusting. And the two conditions is a salt, water or salt conditions, and acidic conditions. So in Mombasa, the acidic and salty conditions speeds up rusting. Hence, cars in Mombasa rust faster. But what about in Kisumu? In Kisumu, water is fresh. There is no salt, there is no acid in Kisumu. Therefore, that's why the cars in Mombasa rust faster than cars in Kisumu, because in Mombasa, the conditions are acidic and salt. So the salt condition and acidic condition speeds up the rusting, accelerates the rusting, unlike in Kisumu. Study the information given in the table below and answer the question that follow. The letters do not represent the actual symbols of element. So we have element S, T, U, V, W, boiling points, and the atomic number. Select the elements which belong to the same group. So you cannot select if you don't know the. So the first thing you must do is to write the electron configuration of each of these elements. So 9W, it is 2 because it is 19, 2 to 8, to 8 to 1. This one is 2 to 8 to 8. This one is 2 to 8 to 6, 2 to 8 to 3, 2 to 1. So the first energy level is always 2. This one, 2 minus 3 is 1. This is the second one, is so the maximum electrons in the second energy level is 8. So you should know those things. Now, elements in the same group, remember the outermost energy level, the electrons in the outermost energy level gives us the group. And the period is the number of energy levels. Like here we have 1, 2, 3, 4. So this is period 4. 1, 2, 3, period 3. Group 1, group 8, group 6, group 3, group 1. So elements which belong to the same group is W, group 1, and S. Right? The same period, period 3. This is period 4, period 3, 3, 3. So T, U, and V belong to period what? 3. 1, 2, 3. Period 3. Which elements that does not form an oxide? Element V does not form an oxide. Explain. It is stable. You can see it has a stability of 8,8. So it does not need to lose electrons. It does not react. It is stable, hence does not lose or gain electrons. Therefore, it does not react. Write the formula of the nitrate of T. T was 2 to 8 to 3. That is aluminium. So you should know the nitrate of aluminium is A. This is aluminium, and then nitrate is this. Aluminium has a valence of 3, so this is the nitrate. So you can write it this way, or TnO3 to power this one and this one. You will get the max. Equation of the reaction between S and U. So let us go and see what was S. S is the valence is 1, like sodium, and U is 16. So now S and U is reacting. So S plus U, it is going to give us SU. But the valence of S is 1, the valence of U is 2. So it is going to put 2 here. S is a metal and this one is sulfur. So we can put 2 here to balance the equation, and that is the equation. What type of bond exists in the compound formed when U and T react? U is a sulfur. So U, sulfur plus aluminium, the bond is, this is an metal and this is a metal. Therefore, the bond is ionic. Ionic bond. Reason: it is a bond formed between a metal and an nonmetal. Therefore, there is complete transfer of electrons from one atom to the other. There is complete transfer of electrons from one atom to the other. There is complete transfer. Let us this one set up so correction of oxygen. So this one is X and this one is manganese 4 oxide. We have 2 methods of preparing oxygen in the laboratory. We use sodium hydrogen peroxide with another reagent, and we usually use water with sodium hydrogen peroxide and hydrogen peroxide. So you should know, whenever we have manganese 4 oxide, which is a catalyst, always remember that we are going to use hydrogen peroxide. So substance X is hydrogen peroxide, written as H2O2. This one is hydrogen peroxide. Whenever we have this manganese 4 oxide, therefore the substance X must always be hydrogen peroxide. Write the equation for the reaction that took place in 13A. So this one is hydrogen peroxide plus, there's nothing plus. This one is the catalyst, which does not react, so we have the catalyst here, which will form water plus oxygen gas. So you put 2 here and you put 2 here. This one is a liquid, this one is a liquid, and this one is a gas, and that is the equation for this is 2 hydrogen peroxide. Chen set up an experiment as shown below to collect a gas. The wet sand was heated before heating magnesium granules. We usually heat this sand to provide steam. So another question you can, why is the wet sand heated first? It is to provide or to produce steam that is going to react with magnesium. So steam will react with magnesium to form, so magnesium plus steam gas, solid, it will give us magnesium oxide plus hydrogen gas. So hydrogen gas is going to be collected. Complete the diagram for the laboratory preparation of the gas. So you should know the gas is hydrogen. So how is hydrogen prepared and collected in the lab? You can use the 2 methods. You can use hydrogen can be collected by over water method or by upward. So you can easily extend this, bring it into water, where we will have bring it into water. Have the gas jar like that. And this is water, and this one is over water method, and you are done. You write here, this is gas, hydrogen, this is water, and this is the delivery tube. So you have completed, or you can use the other one where you will collect it through upward delivery. For you to collect the upward delivery, you must pass it through concentrated sulfuric acid to dry the gas. So this one is the simple one. Why was it necessary to heat wet sand before heating magnesium granules? Is to provide steam. Thank you. Remember to subscribe, please. Don't forget to subscribe.